Okay, let's go ahead and get started on this one. Explain how atoms become ions. So what is it that makes an atom become an ion? All right, so this definition for an ion is a charged particle. And so what you need is it's going to gain or lose electrons. What about the protons? Those are charged. They cannot be changed. You're not going to be changing the proton number. So the only thing you can do is add an electron to become negative or remove an electron to become positive. So cation. Yeah, positive ion, and the anion is the negative ion. Why is lithium happy to form a compound with bromine? Or other way around? So which is it? What's bromine want to do? No.
Metals, they always want to
The metals, just like one instance where we can force a metal to take an electron, and it's not important for us. It's not something that is going to, at this point, we can do it in a lab under very special circumstances. But for you guys, metals only do one thing. They lose their electrons. They become cations. They won't become anions. So when you're looking at this, stuff that's on the left side of that stair step on the periodic table, those are all the metals. And so that's going to be the side that's going to be positive. And then everything on the other side of the stair step, those are the nonmetals, and those are the things that are going to be gaining electrons. So the bromine is the nonmetal in this case, so it gains electrons. And the lithium is the metal in this case, so it loses the electrons. So before the reaction, what's lithium's charge? 0. And then after the reaction? +1. And then the bromine? And after? -1. All right with that? Okay, so oxidation states for these guys. The first one, what's the sodium's oxidation state?
+1.
How do we know it's a +1? It's group 1 rule. All the metals in group 1, that's the only charge they can make. So you can look on your periodic table and it shows you that its oxidation state is only ever going to be a +1. How do I know it's, did I write 0? Totally wrote 0. It's plus. How do I know that this sodium's charge isn't 0? How do I know it already has reacted, it already has lost that electron? It's already in a compound. There's no reason for the sodium and the iodine to sit next to each other as atoms. But as ions, they totally want to sit next to each other because the sodium's a +1 and the iodine's a -1. How do I know the iodine's a -1? There's 2 ways to tell me. It's in the halogen column, and those most likely are going to form a -1 charge, bless you. And then what's the other way I know this? Compound's charge has to be 0. We already know the sodium's charge only option is +1. So to have it be 0, the only other option for the iodine is -1. So sometimes I'm not going to be able to just look at the periodic table and determine what a particular atom's charge is going to be for one of the constituents in a binary compound. But I can look at the other one and say, I know that guy's charge is going to be this, so then the other dude's charge has got to be that. Has to be. Okay, so this one, next one, magnesium. +2. And the sulfur then, -2. How do I know the magnesium's got to be a +2? It's in column 2. It only has one option. It's either 0 or +2. And so then my sulfur is in that oxygen column, so it's probably going to be a -2, but I know it's a -2 because the magnesium can only be a +2. All right, so how about this calcium and this phosphate? What do we got for the calcium? Same reason on the magnesium, right? It's in that second column, so it's got to be a +2. And then the phosphorus?
-3.
Yeah, how's it -3? Has to equal 0. 3 calciums gives us +6, and then that means I have 2 phosphorus that have to cancel out +6. So if I make each of them a -3, then it goes to 0. Copper in this one. Do I know what copper's charge is? Just can I figure out what copper's charge is by looking at the table? I can. If I look at copper, its oxidation state, say 2 or 1, and 2 is most common because it's bolded, but I don't know for sure. But because there's no rule about copper, but there's a rule about chlorine because it's a halogen. So what's the chlorine's charge? -1. So if my chlorine's charge is a -1, and there are 2 of them, then my copper's got to be a +2. Okay. How about this aluminum phosphate? So what's the aluminum's charge? Should be able to tell me that it's +3 for two reasons. The 2 reasons are, one, it's in the third column, and so the aluminum's charge is going to be +3, and if you look at it on the periodic table, it says 3. What's the other reason? Well, yeah, it's positive, but why 3? What is this thing? What is this thing I have circled here? It's a phosphate, and phosphate's charges are -3, period. It's a definition of what a phosphate is. So if I recognize that this thing is an aluminum by itself, and this is a phosphate, and I remember that that phosphate has a -3 charge, then the aluminum has to have a +3 charge because it canceled out. What about inside that phosphate? What's the charge inside the phosphate? What are the phosphorus and oxygen charges? I don't have a hard, steadfast phosphate rule, but my oxygens? -2. So how many -2s do I have there? So total of 8. And then I need to have 3 of those left over, right? So this whole thing has a charge of -8. I need to have -3 left over, so then my phosphate needs to be a +5? 5? Do you want to see that better? About, there's a phosphorus, oxygen, 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 and this whole thing, when I add everything up, has to equal -3. -2, -2, -2, -2. So if that's a +5, that's the only way the math works out. Okay, next one. The potassium. +1 because it's in column 1. And then what's the polyatomic ion that the potassium is attached to? Nitrite. Okay, so 2. So the nitrite is NO2 with a minus charge on it. So that verifies that the plus charge on the potassium is correct because I know that the nitrite's charge is a minus. The oxygen's charge is a -2. I got to be left with a -1, so my nitrogen's charge has to be a +3. So this whole thing has to equal -1, so it can cancel out with the plus on the potassium. So I end up with -2, -2, and a +3 giving me a -1. So my nitrogens are a +3 and my oxygens are a -2. And how about this last one? The sodium's charge? +1 because it's in column 1. The hydrogen's charge? +1 because it's hydrogen that's with, so this one's a little confusing. It's hydrogen with a non-metal. So how do I know that the hydrogen's with the non-metal? the rule for hydrogen is +1 with a nonmetal, -1 with a metal or boron. So how do I know it's with this and not with that sodium? What's this thing I have boxed? It's the polyatomic ion hydrogen carbonate. So that hydrogen carbonate owns the hydrogen because it's, a hydrogen carbonate. So we've got an HCO3 with a minus charge on it. So H, carbon, oxygen, oxygen, oxygen. All this has to equal -1. So -2, -2, -2. Now it's really obvious that the hydrogen is a +1 because it's with carbons and oxygens, and those are nonmetals. And so then what's my carbon's charge got to be? Is it +4? Yep. So 1 here, 4 here, 6 here leaves me with a -1 left over. So with a +4 oxygen with a -2. We have names for these guys? I know we haven't really gone over that, but you had all weekend. Okay. So I'll erase all this. Okay, so sodium iodide, and then the next one? The next one? Calcium phosphide. Next one? That is correct. Copper 2 chloride. Next one? Oops. Just aluminum phosphate. This KNO3? Potassium nitrite. And then sodium hydrogen carbonate.